Alright class, so this video lesson is solely going to be based on in behavior of graphs, and for the years that I've taught this, usually this is one of the more challenging ideas just because it involves infinity. The notation's kind of weird, but let's go ahead and make sense of this. In your notes, go ahead and write, draw a line, write in behavior, and then I want you to put in there example, and go ahead and draw yourself a simple sketch of this. Don't draw the numbers, just do an XY axis and draw this, okay? And then to the right side, we're going to put a definition, a description. This is what in behavior is. It's how the graph behaves as it approaches we say the smallest and we're going to notate that as negative infinity and largest that'll be positive infinity x values. So that's the idea, the largest and smallest x values, okay? And this is how I write this sort of in real words and sort of the directions that you want. So the first thing you want to do is you want to look left. Okay, now you're not literally looking to your left, you're looking at the graph to the left, okay? And then you're asking yourself this, what is the graph doing? We'll say graph. Okay. Then we look to the right, or I'm just gonna say right, so let me erase that. Look right. Okay, and we say, what is the graph doing? All right, so that's always, that's the questions that we want to ask when we're looking at these graphs. So here is delta math. All those notes over there. But here's our instructions over here. Look left, what is the graph doing? So we sort of center our vision on the middle of the graph. So you can see my cursor is hovering over that, okay? Now, if we're here, and let's imagine we turn to the left, we look at the graph, what is it doing? Okay, as we turn to the left. So the left side, that's over here. What is it doing? Well, it's going up, okay? Then we look over here, we say, okay, look to the right, what's it doing? This one's going up, all right? So underneath your graph on your paper, because we want that example on there, go ahead and write this. This is the notation. And it's a very strange notation, but I think you would have seen it last year for iMath 2. We do this, it's x goes to negative infinity as y goes to, and we'll put an answer there in a second, and then it's x goes to positive infinity, y goes to what? So the other way that we could phrase this is like this. This is left, this is right, okay? The negative infinity, that's the smallest value, that's to the left, over here. Negative infinity is over here. And then the right is over here, that's positive infinity. Okay, so what is the graph doing? We said it's going up. Well, the only options you have here are either infinity or negative infinity. Okay, either one of those. But the answer is not negative infinity, it's positive infinity because the graph is in fact going up. So we know that that's going to be our first answer. Let's look at our options here. Delta Math's going to have this as multiple choice. These are the only 4 ever possibilities for this. By the way, another way to phrase y is f of x. So I'll put that there as well. That's how they have it. So we start here. As x goes to negative infinity, y goes to positive infinity. So which ones show that? X, negative infinity. So this one is good so far, and this one. So these first two potentially will work. These, however, will not work. Okay, so it's one of these two. So then we just look to the right. So I look to the right. So I'm here, look to the right. What's it doing? It's going up. So this is also positive infinity. So we look at our answer choices. This is the correct answer for this one. Okay? This is the correct answer for this one. So I'm going to go back up, and I'm going to go ahead, or actually I'm going to go down and submit. Yes, and I got it right. By the way, let's go back up, because there's two ways we're doing this. So this example, put the word graphically, because that's what we're doing right now, is we're looking at a graph to tell in behavior. Let's go ahead and get a new problem though. Oops. Okay, so here's the next problem. I'll do this one with you, and then we're going to start putting examples in here for you. So what is the in behavior of this? So I look to the left. Let me go down. It's always going to be in this form. This is to the left. What's it doing on the left side? So I'm here in the center, look to the left. Oh, it's going up. Okay. So then when I look at that, that means I'm going to put infinity for y. Okay, then I'll put the next one. This is to the right. What's it doing on the right side? Well, it's going down. So that is to negative infinity. And we got it. Let's see which one that is. Okay. So as x, these all show x, so this is the right side first. So we know it's either going to be this one or this one. They've mixed these up, by the way, to try to make sure that you're paying attention here. And then we know that as it's going to negative infinity, phone call, hold on. As it's going to negative infinity, it needs to be going up. So the top one is the best answer for us. Pause my recording real quick. All right, we're back. So we answered this one correct. Now what I want you to do is I'm going to give a new problem here, and I'm just going to show the graph and the answers. So you can look at that for a second. Pause it. I'm going to put up a question. You're going to say 1, 2, 3, or 4. These are just 1, 2, 3, 4, how they're listed there and ordered, and you tell me the correct answer. All right, so the explanation is it's going up both directions. So we know that both of these, and that's sort of how you can do this. We know that both of these should be positive. If it's going up both directions, both should be positive. So I'm looking for the y going to positive for both of them. That's sort of my game here. As it goes to the left, it's going up. As it goes to the right, it's going up. That should work. Let's do 2 more of these. Here's one here, and this one looks pretty much like the other one. So go ahead and answer. Once again, both are going up. So as x goes to negative infinity to the left, it's going up. As it goes to the right, it's also going up. So it's this one here. Let's find an interesting one. All right, we'll do this one. Look at how crazy that one is. Okay, so this polynomial here. Look at the answer choices. I'll pause it. You tell me what you think it is. 1, 2, 3, 4. All right, so both sides, as I look to the left, it's going down. So going to the left is the first option, and it should be going down. So it's going to be one of these two here. All right, the right side, it's also going down. So it actually has to be this first one. So hopefully you put 1. And that's that. All right, cool. Start a new page. Let's do in behavior. Algebraically. Or no. Let's actually say from a function. That's what we're going to put. From a function. All right, so let's go back. Let's look at this. So it says algebraically, but look at how wild this equation is. So in your notes, we're going to write it down. Let's go ahead and do that. F of x equals negative 10x to the 6th plus 400x cubed minus 2400. Let me go ahead and give myself some more space here. minus 1200x squared minus 3520x plus 250x to the fourth. What a long equation. And you know, we just did graphically, but I'm gonna go ahead and tell you, graphing this would not be good, because it would, first off, it would take forever to type in, and you probably would have to zoom out and change your scale tremendously. But technically it would work, but you just have to make sure that you know, are able to get it to where you can actually see it. But this one would be really hard to see. The y-intercept itself is 2400, negative 2400. So, all right, let's talk about what you want to do. For algebraically looking at in behavior, we only care about one thing. We're only looking at one place. So here's the note that we need here. Only use the lead coefficient. All right, so look at the equation that we wrote down, or you can just look at it over here. What is the lead coefficient? Well, we need to remember the lead coefficient is the one, not that because it's in the front, always. Usually it is in standard form, but the one with the highest power. So which one of these has the highest power? Well, it's going to be the negative 10x to the sixth, okay? So this is all we need to be able to answer which one is correct, okay? So let's talk about what we need, okay? First off, we want to consider the concavity, is what we call that. Now last year, concavity, you would have seen that in parabolas, okay? Don't write this, you don't need to write this, but if I drew a parabola, this would be considered concave up, this would be considered concave down, and it was that simple, okay? And what determined that was the A value, the leading coefficient. So I need to actually change this. Erase coefficient, we need to use the leading term. I said that wrong. So this is the lead term, negative 10x to the sixth. So we're using the lead coefficient to determine concavity. Well, what does concavity actually tell us? This concavity, it determines the direction of the graph on the right side. So this is that idea of look to the right, and when we did it with graphs, you could just, you knew if it was going up or down. It's pretty easy, okay? So I need to maximize this a little, or make this bigger, okay? Scroll down. And we're going to add this note. This is determined by the lead coefficient. All right, so this is what we're looking at. So we're going to write it this way. If you have a positive A value, it's going up, or we'll say y goes to positive infinity. If it is a negative A value, that means it's going down, or y is going to negative infinity. And this is on the right side, okay? Only the right side. So I'm looking at mine. Here's my lead coefficient. The A value is negative 10, so that means it's on the right side, it's going down. All right, so for our example up here, I'm gonna write over here, we wanna write our answer. So it's as x goes to negative infinity, y goes to, we're gonna put an answer there, as x goes to positive infinity to the right, y is going to, well, we just determined by that -10, that it should be going up. So our only answers right now should be either this one or this one. It's one of these two that are going to be correct, okay? So how do we get the other direction? Okay? The last thing that we want to determine is what is the other side doing, and how do we determine that from the lead coefficient? Well, we want to look at the degree. We've talked about degree already, and it should be in your definitions that you defined. Degree is equal to the highest power of the polynomial. Well, what is our highest power? It's 6 in this case, okay? But degree is what determines the end behavior of both sides of the graph. And what we're looking for is if the degree is even or if it's odd. So we have even and we have odd. So two things occur here. If it's even, then the graph's end behavior, it ends in the same direction. If it's odd, it's opposite directions. So odd, opposite. Okay? So that's where we're at with this. And we know that we have an even power. Okay, it's 6. 6 is our highest power right here. Okay? So 6 is the highest power. If I go to my little notation over here, we said we already know that the right side is going up. Since it's even, they're going in the same direction. Okay? That's what we said right here. So this even is the same direction. So that means that this will be positive infinity. Okay, so let's find that. We know that that's not going to be it. It's going to be this one. X goes to negative infinity, positive. Oh, wait. That isn't right. It's this one down here. Okay, negative to positive, positive to positive. Okay. Submit. What happened? Oh, they should be going both negative. I got confused. Whoops. Let's try a new problem. Let's try this method again. Okay, highest power is 2. First off, this should be negative. I didn't put a negative here because it was a -10. Somebody probably caught that as I wrote it, but you couldn't tell me because you're watching this video at home. All right, so those are both negative. Sorry. All right, so this one here, I'll write over here. So this one here, as x goes to, we have to the left and x goes to the right. First, we're going to start with the right side. Remember, the a value determines what it does on the right side. So here's our leading coefficient. What's the value in front? Well, it's a 1, positive. So since that's positive, it's going to go up on this side. All right. Now, the highest power is even. So that means it's going to go the exact same way. And that's it. That should be our answer. So let's look at that. It should be this one here. I got it right that time. Let me do one more. Okay. So on this one, highest power is this one. That's what we're looking for, leading term. Notice how it's a -3. So when we're writing this out, x goes to negative infinity and positive infinity. So as x goes to positive infinity, so this is to the right, this is a negative number, we know that this should be going negative. What's the highest power? Is it even or odd? Well, it's a 4, so it's even. They're going the same direction, so these are both negative. Okay? All right, so which one is that? That's going to be the first one here. Both are negative. So now you're going to try one. Let's see how you do. I'm going to go ahead and pause this, put 1, 2, 3, or 4 as the answer. All right, you had time to answer. The highest power is 3. This is the lead term. Notice how it's a negative in front. That means that it should be as it goes to the left. So this is going to the right. Here's our right side. It should be negative. So it's one of these two. So if you put 1 or 2, you're on the right track. Then it's an odd power. Okay? So if we put this first, we know that the other one has to be opposite. So it's going to be 2. So hopefully you put 2. You got that right. Let's do one more. All right. I'll give you a few moments. 1, 2, 3, or 4. All right. So let's go ahead and do it. So we're looking at the 5 first, because this whole term, 5x cubed, is our lead term. The coefficient on that is positive, so that means as we go to the right, so here's the ones that are going to the right, okay, we need it to go up. So it's going to be this one or this one. It's going to be either the number 1 or number 4. So did you put 1 or 4? Okay. Then it's an odd power, so we know that it's going to be opposite. So it's actually got to be this last one. Okay, so that's in behavior. There are practice problems in Delta Math that you need to do. If you have more questions about this, send me an email. Let me know if you're having trouble. This is something that is typically kind of difficult for students. Look up videos, look up resources online to help yourself, learn it, or go back and watch this video again. You can go to my YouTube to move and fast forward through it. You don't have to hit restart on this. But again, if you have questions, try to reach out to me.